Well, let's take a look at our last section of review. We're looking at skills 20 to 29. So just quickly, here are some things to remember about the different skills. Skill 20, graphing from a table. In the table, we'll be provided with a table. We might have to complete the table. The column or row of that table that is labeled as the X, that's the number that we're going to use to go across on the graph. And the other column or row will be either labeled as a y, or it might be using function notation. It might be called f of x, which refers to the same thing on the graph. So it's the y coordinate, whether it says y or f of x. That's the number that goes up or down on the graph. And you need both numbers, two numbers in the table to create 1 point on the graph. So skill number 21, finding intercepts. The intercepts, the most important thing we got to remember is that for each of the intercepts, there's going to be a 0 involved as one of the coordinates. The x-intercept is going to have a number for x, but the y-coordinate will be a 0. And for the y-intercept, it'll be switched. The y-intercept is going to have a y-coordinate. That's the second number in the pair, but x will be a 0. And so if we're given a graph and asked to identify the intercepts when we give our coordinates, it should match this form. If we are given an equation and asked to work out what are the intercepts, this is the piece of information we're going to start from. Take the equation, and if you need to find the x-intercept, you're going to erase the y out of the equation, change it into a 0, and then you're going to solve for x. And likewise with the y-intercept, you're going to take that equation, erase the x, and change it to a 0, and then solve to find whatever the y is. That'll be the y-intercept. If you're given a table and you need to, or a list, and you need to identify which of those points is the intercept, look for the ones that have zeros in the appropriate places. Skill 22, finding slope. A couple of ways to do slope. It's rise over run, or we can use our slope formula, subtracting the two y coordinates to get the rise, and subtracting the two two x coordinates to get the run. Slope is always going to be reported as a fraction. That's what the over in rise over run means. Skill 23, graphing equations in y equals mx plus b is going to give us a line. Start from the y-intercept. That's the b part of the equation. Do that first. And then m is the slope. You're going to count spaces on your graph to get the rise and the run to find your next point on the graph. Skill 24, graph is graphing or making equations in point slope form. Mostly this is graphing. So point slope form is this one that is given here, the x1 and the y1. Those go together to create a point. That's where we'd start our graph from. A couple of things to remember about this. Often people get confused when you look at the equation because the first number, you'll think, oh, that's like the number I write into my coordinates first. But it's the y, and y is always the second number in the coordinate pair. X, even though it's the second or the last thing there in the equation, that's going to be the first number in your coordinate pair. The other thing we got to remember is that since point slope form has these built-in negative signs, and those negative signs are part of the equation, not part of the coordinates, we'll always have to flip the sign. What it says in the equation is going to be the opposite sign of what we actually use in the coordinates. Okay, skill 25, identifying and changing between the three different forms of linear equations, so slope intercept, point slope form, and standard form. Those are the only three forms that we will use. Skill 26, writing equations, not graphing, but writing equations in slope intercept form. Still got those same two things to identify. M is going to be the slope, B is the y-intercept. Skill 27, interpreting the slope and the intercept. When we interpret an equation that's written in slope intercept into a story or a context, the m, that slope, always will represent a rate. That is our interpretation. So a couple of things to remember about rates. There will be two different units. For example, dollars per day. Dollars is one kind of unit. Days is the second kind of unit. They measure different things. So there are two units. And the word per, or some variation on the word per, that's going to be what we use to identify a rate. The b, that's the y-intercept. In context, when we interpret it, the y-intercept always represents a starting amount. So if you started saving money and you get like $3 every week, but you started with $40, and that's our equation we're interpreting, the $40 is going to be the starting amount, right? And then the amount that you're saving each week, that's your rate. Okay, skill 28, writing equations in point slope form, similar to when we were graphing. You're going to put the coordinate, the x coordinate goes into the x spot, and so that's the first number in your coordinate pair, but it goes into the end part of the equation, and then the y1, that's where your y coordinate goes. Y is the second coordinate in your coordinate pair, but it goes in the first blank spot of the equation. M is the slope. And then lastly, writing equations that are parallel and perpendicular. And we always wrote our equations using point slope form. You don't have to do that. I mean, there are other options. You could use slope intercept form, or you can use standard form, although we've not learned about writing equations in standard form, but you could. The thing we have to remember is that in order to determine whether a line is parallel or perpendicular, we look at the slope. Parallel lines have the same slope. And so if we need to write an equation that's parallel, we got to use the same slope as the line that's pictured in the graph or the equation that we're given with to start from. Perpendicular lines do not have the same slope, but it's not just any different slope. It has to be changed specifically in two exact ways. The slope of a perpendicular line has to be the opposite reciprocal. Opposite meaning opposite sign, so if one's positive, the other's negative. And reciprocal is where we take the numerator and the denominator and we trade places. Or you could say the rise and the run trade places. Okay, well, let's look at some of the actual problems here in the practice test. So the first question, number 1, is about slope. I pulled 2 different examples here to look at. One is a positive slope and the other is a negative slope. So I'm going to start here on the one on the left to get my graph walker ready. So first thing we'll have to do is identify some points, and we would not want to pick a point like what I just drew here with the red point, because that is not on a integer value. It's not on one of the graph paper intersection lines, and so that would be a bad choice because we wouldn't be able to find out exactly where that point is. We'd have to guess. So what we're looking for is someplace that line goes through graph paper intersection lines, and then there are a whole bunch of choices in this case of places we could use our point. Okay, any of those green dots would work, but we only need 2 of them. So pick your 2 favorite ones. Doesn't matter which 2. Pick your 2 favorite ones. And then we're going to find our slope using I'm going to use these 2. So my graph walkers always go from the left to the right. And in this case, my graph walker would be going down the line, right? And so that tells me this is a negative slope. So I'm going to remember that when I get ready to write my answer. This should be a negative slope. And I'm going to count spaces from the first green dot to the second green dot. I'm going to count how many spaces on the graph I would go up or down, and that'll be the rise. I'm going to put that in quotation marks because in this case, I'm actually not rising, I'm going down, but that still is the rise. So 1, 2, 3, 4. Since I went down, I'm going to make it a negative, and it was 4 spaces. And then the run, I'm going to just count spaces that I go across, and in this case, that is 2. So my slope is going to be the fraction. I put the rise number on the top of the fraction, the run number on the bottom, and then we always simplify our fractions. So in this case, -4 divides by 2 evenly. I just get a final answer of -2. So to put that down here in my answer box. And then I'm going to do the same process over here on the next graph. So I'm going to bring a copy of my graph walker over here. So I need to pick some points. There are a couple of different points that you might use. Actually, there's one other one here right here you could use. I'm just going to choose 2 of them. It doesn't matter which 2, but pick 2 points. And then the graph walker on this line is going uphill, so I know my final answer should be positive because he's going uphill. And then here's my rise. So I'm going to count. There's 1, 2 spaces. And then my run, 1, 2, 3, 4. Put those together into a fraction. Slope equals the rise number is going to go on the top. The run number is going to go on the bottom. Always simplify our fractions. It's the same as 1/2. 1/2 goes down here. Okay, also a slope question. This time I'm given the coordinates of some points, -10, 3 and 5, 7. I need to find the slope between those 2 points. So I'm going to use my my slope formula. So I need to identify the y coordinates because those are going to go onto the top part of my slope fraction. So I'm going to highlight both of the y coordinates in green. I'm going to subtract those two. Slope equals. Here's my fraction line. So those two green numbers, I'm going to put those on the top. Let's get some extra labeling going on here. So more colors. I'm going to call this one 0.1 because it was listed first. I'm going to call this one 0.2. You could totally switch that around if you wanted. I mean, it kind of is weird to start with point number 2 and then end at point number 1, but you can. It would work. So anyway, I'm going to subtract the y coordinate from point number 2, which is 7, and then I'm going to subtract this other one, which is 3, and then highlight the x coordinates. I'll use magenta here. So there's my two x coordinates, and subtract. I'm going to write in red. So starting from point number 2, the x coordinate was 5. So I'm going to go 5 minus, and then the other x coordinate is -10. So we're going to have both the minus sign and the -10. Since the coordinate was a negative, that's got to have a negative, and the slope formula always is subtracting. So I am subtracting a negative number here. When I subtract a negative number, that's the same as adding, right? A double negative is like adding. So I'm just going to write that as a giant plus sign right there. Let's subtract the top two numbers. 7 minus 3 is 4. The bottom, I ended up adding 5 plus 10 is 15. And there's my slope fraction. Reduce it if possible, but in this case, 4 over 15 does not reduce, so that would be my final answer, 4 over 15, written as a fraction. All right, question 3 involves graphing. I'm given a graph, rather, and I need to write the equation. So the two pieces of information I got to figure out are what's the y-intercept and what is the slope. So the graph's already drawn, so I don't need to start at the y-intercept. That's important when I'm drawing the graph, but I'll go ahead and do that since I did list the y-intercept first. So wherever that line on the graph crosses the y-axis is the one that goes up and down, so it's that blue spot I just highlighted, and that would be at -6. It's not clear from the directions whether it wants me to give the coordinates of that point or just say what is the y-intercept. So I'm just going to list the y-intercept. That's what this problem is actually looking for, despite the fact that the directions are not super clear on that point. Oops, I got my colors backwards. I highlighted the y-intercept in green. Why am I working in blue? Oh, no. Change this all to green. That's -6. Okay, and then I need to find the slope. I do not have to start from the y-intercept to find slope, but I do need 2 points on the graph to find slope between. So I'm going to use this yellow point right there. I'll just highlight them rather than drawing the dots. And the reason I picked that point is because that is where that green line on the graph goes through some graph paper intersection lines. So now I can count spaces to get the rise and the run. My graph walker standing right there, it'd have to go down 1, 2, 3, 4, 5, 6. So I'm going down, I'm going to call that negative. That's my rise. And the run is 2 spaces. So when I put those together in fraction form, the rise number goes on the top, the run number goes on the bottom. Simplify, and in this case, -6 divided by 2, it divides evenly. It's going to give me a slope of -3. So I don't need to write, if it's a whole number, I don't need to write it in fraction form. I can just give the whole number. So the slope is -3, y-intercept -6. Okay, now the reverse process, and I'm graphing this equation. So this time I do need to start from the y-intercept. That's -1. And then I'll use the slope to get my next point. Try to keep track of my colors better this time. Okay, so starting from green, that's the y-intercept. So on the y-axis, I'm going to find -1. The y-axis is right in the middle of this graph going up and down. So there's my -1, put a dot there. And then from that point, I'm going to use the slope I'm going to count the rise and the run to get my next point. So the negative, I'm going to include that as part of the top number of my fraction. So -1 means I'm going to go down 1 space from that green dot. And then the 8 is going to be the run. So run always means going towards the right. So I'm going to go down 1 space and then 1, 2, 3, 4, 5, 6, 7, 8 spaces over. That's my next point. And then I can draw a line. Whoops. I was not actually watching what I was drawing. There. Turn that into a line. Cool. The end. Okay. Question number 5 involves completing this table. And the skill we called graphing from a table, and we do actually have a graph hiding down there. It's not just completing a table. So fill in the t-table for the equation below, labeled with x's and y's this time. So I'm going to use this equation. I've started off by just creating a version of that equation where the x is blank, since I'm going to have to fill in these different numbers out of the table as my x number. So let's just, well, let us not highlight this. Let's pull out a couple of different copies of this. Since there are 3 numbers in that table I will need to use. So I'm going to start with the top one, which is -3. So I'll put a -3 into this x spot and then evaluate to start and solve for y. So 2 times -3 is -6. And I'll try to get the y by itself. So I'll add 6 on both sides, which gives me 3y equals 9. And then need a tiny bit more space. Divide both sides by 3. So 3 divided by 3 equals 3. Okay, so my y coordinate in that first spot there is going to be +3. Next is a 0. So I'm going to put 0 in here into the x spot and solve this equation for y. So let's multiply 2 times 0. That's 0. I don't really need to write the 0. So I wrote the 0 because I did multiply 2 times 0 and I got 0. But 0 is nothing. I don't actually need to keep that. So I'm going to erase it. The plus sign is not needed either. If there was a number there, I would be adding, and so I need the plus sign. But in this case, since there's nothing, it's like nothing plus 3y. It's just the same as 3y. If I erase the plus sign, it's a little bit less confusing to look at what's left here, and that still means a positive number, whether I have the plus sign written there or not. So divide both sides by 3, and y equals 1. 1 is going to be the y coordinate. I'm going to put that into the table. And then lastly, the 3, +3, is going to go into my equation. +3 right here. Multiply 2 times 3 is 6. And then to solve for y, I'll need to subtract 6 on both sides. So 3y equals, and 3 minus 6 is -3. Divide by 3, and y equals -1. So I'm going to put that -1 into the table here. And then once I've completed the table, I'm going to plot those 3 points. So I use different colors to keep track of those 3 different points. So the red one, -3, +3. The x coordinate, I'm going to go either left or right. Since it's -3, that means I go left 3 to -3 and then up to +3 before I place that 1 dot. 2 numbers together on the graph make 1 dot. The blue one is next, 0, 1. The 0 is the sideways measurement, so I did not go sideways at all. And the 1 is the up and down number. And the purple one, 3, -1. So I'm going to go to the right to +3 and then down to -1 before I place my dot. And those 3 dots should line up in a straight line. If I held a ruler up to that, it would give me a straight line. I don't need to draw the line to connect them, and on WAMAP that won't be possible for you to do anyway. Just placing points in the appropriate location. But I should be able to tell that those dots line up perfectly. So without actually drawing a line, whoops. Oh, my ruler is up here. Couldn't see it. Now I got 2 rulers. I should be able to just line up some sort of straight edge on the screen to say that, yeah, those do actually line up in a straight line. So if they didn't, that would tell me that I'd made a mistake someplace, either in plotting the points or in calculating the numbers that went into the table in the first place. They should make a straight line. All right, question 6. Graph the line described by y minus 3 equals negative 1/3 parentheses x plus 3. So it's an equation in point slope form. So I need to identify these two pieces of information before I can graph. I need the point and I need the slope. So the point is going to come from these two places. This one is the x coordinate. I know it's at the end of the equation, but that's got to be the first coordinate. And so it says in the equation positive 3, but we always switch the sign because point slope form is built with negative signs. And that means when we take that negative sign back out and leave it as part of the equation, what we get out as a coordinate will always be opposite sign. And the y coordinate over here says minus 3 in the equation, but when I change that sign, it gives me positive 3. So the coordinates of my point, negative 3, 3. I'll go ahead and graph that now. So negative 3, 3 is right here. And then the slope is between the equal sign and the parentheses, negative 1/3. So that is what I will count as my rise and run to get the next point on the graph. So starting from the red dot, I'm going to go down because it says negative. I'm going to go down 1 space, and then to the right 3 spaces. There's my next point. I could repeat that process. If I was drawing this on paper, I would repeat it, repeat it, repeat it. So I have a lot of dots to make sure that they all line up and I get a perfectly straight line. But since we're doing this on WellMap, it's going to draw the line for you. Let's see if I can get this line to go through the dots on the first try. Yay! We'll put some arrows on there. All right, question 6, also in point slope form. And so I need to identify those same pieces of information, but this time I'm starting from the graph. And so the coordinates of that point, negative 1, negative 4. The slope I'm going to have to count. So I need a second point on the graph so that I can count my rise and run. So I'm going to go up 2 spaces. I'm going to go across to the right 5 spaces. Write that as a fraction. So my slope is 2 over 5. And then the slope is going to go into the m spot. And x coordinate out of that point goes over here in the x spot. The y goes over here in the y1 spot. So in the answer box down there, I would write y minus negative 4. I'm going to combine the minus and negative 4 and to make it a plus. I haven't done that yet, but I will. And then parentheses x minus, and that x coordinate is a negative 1. I will also change that minus a negative to make it a positive number for my final version. So y plus 4 equals 2/5 x plus 1. All right, so question 8. Determine whether the following pair of lines are parallel, perpendicular, or neither. So we're going to have to identify the slope out of those two lines. That's the only thing we need. So the first equation, it's got a slope of 4 over 6. The next equation, negative 4 over 6. So they are opposite signs, but that is not quite good enough to make them perpendicular. Perpendicular, they need to be opposite and reciprocals, and they are not reciprocals. They both have a 4 as the numerator and a 6 as the denominator. A reciprocal would be if we flipped one. So it means they are not perpendicular. They're also not exactly the same as one another, so they can't be parallel either. Parallel, they'd have to both be exactly the same, not one positive and one negative. So not parallel, not perpendicular, that means neither of those apply. So select neither out of that drop-down menu. And then question 9, here's our last one. Consider the equation y equals negative 5 over 7x plus 2. And then we need to write a parallel. It's not right. We need to write the slope of a line that would be parallel and then the slope of a line that would be perpendicular. So we need to identify the slope in that original equation. We don't care about anything else except just the slope. So negative 5 over 7. Parallel lines are going to have the same exact slope. So the first one, a line parallel to the above line, would have a slope of the exact same thing, -5/7. And perpendicular lines, the slope has to be the opposite reciprocal. So we would need to change the slope in these two ways. We'll have to change first the sign, so it would be positive, and then the reciprocal. So I'm going to take the rise and the run, switch them. 7 is going to be on the top, 5 is going to be on the bottom. Positive 7/5 would be our answer. Probably writing the positive sign in there is going to make WAMAP not happy with us. So it is actually positive, but probably don't write the plus because WAMAP will be confused.